Hey guys, this is Eric with Cornerstone Performance. Today we're going to talk about angle shooting with a rifle and why it doesn't matter. Three quick disclaimers. Number one, this is not for precision rifle shooting, either as a sniper in a competitive environment. This is the patrol marksman scenario, a patrol officer with a magnified optic and an accurized rifle shooting at realistic distances at partial targets. So small, high-risk targets. We're talking about 3-inch circles and 8-inch circles is our target area for this. Second disclaimer, we're only talking about elevation, not wind. Wind does something different and it does matter, but we're not going to talk about that right now. Third disclaimer, some of the numbers that I'm going to use are based off of my patrol rifle. So I have a 12.5-inch barrel shooting 75 grain Speer Gold Dot, moving 2,400 feet per second. So all of the data that I'm going to use comes from that. That is a worst case scenario. It is a short barrel shooting a slow, heavy bullet. So if you're shooting a 16-inch barrel with some 5.56 pressure, 62 grain ammo or something like that, you are going to have less drop, and all of this matters even less to you. I'm going to use two examples for this angle shooting scenario. Both of them come from Wimberley, Texas. So in Wimberley, Texas, there's Old Baldy Park. You climb up to the top of the hill. There's a scenic overlook. Whenever I got to the top of the hill, I looked around. You can see some houses down at the bottom of the hill. And I thought, man, for a patrol marksman scenario, this would be ideal. So I'm up at the top of the hill providing overwatch for a barricaded subject or something like that. There was a house at the bottom of the hill and a house at the bottom of the hill and across the street at about twice the distance. So I got out my app, I measured the elevation, and I got distance, line of sight distance, like your rangefinder would give you, to both houses. So we're going to use both of those as a real world example to talk about shooting from elevation. I'm going to show you how to get data for yourself so that you can figure all this out without my help later on. So first we know how high we are and how far we are away from the target. So if we're up here at an elevated position and our bad guy is down here, if we get our rangefinder and we look at him through this, this is what our rangefinder will give us, but our bullet drop is only dependent on the actual distance from us to him. Just horizontal distance, not line of sight distance. Our line of sight distance will be greater. That could potentially create problems for us. We're going to figure out if it's something that we really need to worry about in a patrol marksman scenario. Now, I've already worked out all of the math. So rule number one, never math in public. And so I've already worked out all of the math. Let's talk about what we came up with. For the closest scenario, I was at 118 feet in elevation. So I was 118 feet higher than the guy over here. And I was 110 yards. So 110 yards, now we've got to convert that to feet, is 330 feet. Now remember from high school geometry, the way that we work this out is a squared plus b squared equals c squared. So this would be a, and this is b, and we're trying to come up with c. What was my line of sight distance so that we can see what the difference is between the two of these. We work out the math. So 118 squared comes out to 13,924. 330 feet squared is 108,900 feet. Now you add those two together, you end up with 122,824. Take the square root of that, and we are at 350 feet as we look at the bad guy down there. That 350 feet comes out to 117 yards. Now, that is important for us because bullet drop is only going to be 110 yards worth of bullet drop, but whenever I get out my rangefinder, I look at him, it says I'm 117 yards away from him. So what does that mean in the real world? Remember, we're using a worst case scenario here, short barreled rifle with heavy, slow bullets. Worst case scenario, what does this come out to? So my bullet drop is dependent here. this is what my bullet actually drops. And for 110 yards, my bullet would only be dropping, because I'm a good American, I use a 100-yard zero, only drops 0.1 inch. My 117-yard data comes out to 0.23 inches. Now remember, this is what my rangefinder, if I just look at my rangefinder, then I'll look at my little dope card, I check my app, my rangefinder would tell me, my app would tell me, hey, you need to hold 1/4 inch high. I would actually need to hold 0.1 inch high. That means that the difference between the two is only 0.1 inch. It is less than the diameter of this Sharpie. So angle shooting in this scenario doesn't matter. I took pictures from the top of the scenic overlook at the two houses, and I'll drop those in the comments so you can kind of see what I was seeing. Now, we talked about there was another house across the road, so it's further away, and the mountain kept dropping off, so there was more drop. So let's talk about what that would look like. So this is kind of maybe a worser case scenario. So it was longer and higher up. So here we are up here, and here's bad guy down here. So we come up with, we are at 141 feet for this one. So 141 feet higher. Now, stories. So if you're looking at a building, you're like, okay, well, I'm not going to be on top of a mountain, but I might be in a, on a balcony or on top of a parking garage or something like that. 141 feet comes out to about 12 floors up, which is a long, long way up to be doing Overwatch. The organization I work for, people are occasionally called on in a patrol atmosphere to have to provide Overwatch for stuff. Being 12 stories up is just crazy. That is not something that is typically done in a patrol marksman type scenario. The 118 feet, that's 10 floors up, which is still really, really high. So imagine being 12 floors up. Line of sight distance was 172 yards, which comes out to 516 feet. Whenever we do the math, we're just going to shortcut to the math, and this comes out to 178 yards. So remember, this is bullet drop, and then this is what our rangefinder tells us we need to drop. So app would say that we need to hold 3 inches high. So app says we need to hold 3 inches high. We would actually only get 2.6 inches of drop for a whopping 1/2 inch of difference. That is less than the diameter of a big fat Sharpie. So we're talking about hitting someone in the top of the eye socket or the bottom of the eye socket. Angle shooting in a patrol marksman scenario doesn't matter. To put this in context, most city blocks are about 100 yards long. That's how long they are where I'm working. So we're talking about being 10 floors up, shooting somebody 1 city block away, or 12 floors up, shooting somebody almost 2 city blocks away. So an entire city block and an intersection and another half of a city block is what we're talking about right here. That is wildly unrealistic. In real world scenarios, that's just not a thing that is happening in police settings, and certainly not in civilian settings. So this is how you work out the math. A squared plus B squared equals C squared. Then you just get out your little calculator. Okay, I know that 110 yards was 0.1, 117 yards was 0.23. My difference is 0.1. Does that matter to me? The answer in a patrol marksman scenario is always going to be no. This is how we work it out. I'll drop pictures of the actual houses down in the comments. It is a long way. 172 yards is a ridiculously long way to be engaging somebody. And being 141 feet above them, I had to go to a scenic overlook to put myself in that scenario. I take pictures and I try to find situations where angles would matter, and I had to go to a scenic overlook to be able to find one where it would potentially matter. Now, another thing to remember is that the steeper the angle, the more difference this makes. So if we leave this at one city block, but then we go up, say 20 stories, our angle is very steep. And this, our C squared, will be very different than our B squared. So it becomes more of an issue. I ran the numbers, even if you go all the way up to 20 floors. So I'm going to shoot one city block away. I am 20 floors up in the air. It still doesn't matter. You have to get, say, 50 floors up in the air before it starts making a difference. When we get 50 floors up in the air, like now you are 600 feet in the air, you're 200 yards in the air, and target discrimination becomes an issue. Like you can't pick out the right person to shoot. When you're 200 yards in the air, shooting 100 yards away, we start talking about what ifs and imaginary good idea fairy kind of scenarios rather than real world application. So the steeper the angle gets, the more it matters. The longer the shot is, the less it matters. So the further away somebody gets from you, the less of a problem this is. So what are the things that we need to worry about instead of angle shooting? Well, number one, we need to set up our gear properly. We want to set up our optics so that the eye relief is optimized for us. We want to make sure that the optic is level and that everything is torqued correctly. After we do that, we want to know what our zero is. For sure and for certain, with 10 round groups, we zero at 100 yards. After we do that, we confirm with a 30 round aggregate. And then after we do that, we test rel flex. So if I'm shooting off of a bipod or a bag at the mag well or off of the magazine, does that affect my point of impact? It probably does a lot more than you think that it might, based on my experience in testing a lot of even the really good rigid rails. You will see point of impact shift enough that it might matter at extended range. After we know that our gear is set up properly, we know that we're zeroed, and we know how point of impact will be affected by barricades, we learn to get into barricade support positions reliably and efficiently so that every time we approach any sort of barricade, we can get there, build a stable support position so that we can be as accurate as we have to be as fast as we can. Those are the things we need to spend most of our time worrying about. After all of that is 100% reliable, then we can start thinking about the half-inch difference that you might get if you're 20 floors up shooting at somebody inside of one city block.